Welcome everyone. This is VPC Network Peering, where we will start with a recap on the default behavior of VPC network connectivity. Then I'm going to explain why you may want to use so-called VPC Network Peering feature of the Google Cloud Platform. And then at the end, we will take a look at configuration for VPC Network Peering and see how to use it in the cloud. When it comes to connectivity and VPC, or just virtual private cloud networks, remember that VPC networks are isolated resources, which means that no traffic, no communication can be established between two different VPCs, no matter if they are part of the same project or if those VPC networks belong to different projects. And this applies regardless of the zone configuration, region configuration, the actual subnet used in one VPC or another. Simply remember that when you have two different VPCs network in a project, they will not be able to talk to each other, and the same also applies when you've got VPC networks in different projects. And this isolation is something that actually is required because it reduces the risk of unauthorized access and data breaches. This is why Google designed the cloud in this way. By default, VPC networks are not supposed to reach each other. As you probably guessed, the VPC network peering feature of the Google Cloud Platform is something that is going to eliminate this default VPC isolation. VPC network peering is what enables IP connectivity between two VPC networks, no matter if they are in the same project or across the different projects. VPC network peering can be established even with VPCs that belong to different organizations. Now, as a result of a VPC peering, resources in the two VPCs that we peer will be able to reach each other, assuming that the firewall policies allow for that, and the experience is going to resemble a single VPC communication, which means that the latency, throughput, and availability is going to be the same as if the resources were in a single VPC network. The peered VPCs, as I said, can belong to the same or different projects. One additional thing to remember is that Google Cloud is going to automatically share routes to enable the seamless communication. But notice that by default, the cloud is only going to share private IP version 4 prefixes or just subnets. For instance, if you are using some public IP addresses, they will not be by default shared, exchanged. But there is an option that allows you to configure exchange of static routes, dynamic routes. This is something that you can configure for the peering. There are some limitations associated with this feature. First and foremost, remember that the subnets that belong to VPC networks you want to peer must be different and they cannot overlap. So for instance, if you try to peer two VPCs that both use the default VPC networks, if you try to peer both of these VPCs, both of these default VPCs, this is not going to work because both of these networks use the same IP subnet, 10.128.0.0/9. And the same is going to apply when you try to peer a custom VPC network with the default network, as long as the custom VPC network uses subnets that overlap with the default VPC network. And because of that, remember, before you configure a peering, the first thing you want to make sure is to check if the subnets used in those two different VPCs are not the same and that they don't overlap. The second limitation is that VPC peering does not provide transitive routing or communication. What I'm trying to say that if you peer between, let's say, VPC network A and B, and then between B and C, you create two VPC network peerings, one between A and B, and then the second peering is between B and C. It doesn't mean that A is going to be able to reach C or vice versa. This is actually not allowed. Transitive routing and transitive connectivity is not an option with this feature. Before you start configuring a VPC network peering, make sure that both sides of a peering are aware of the process. Ideally, if it's just you who administers both of those VPC networks, but just in case if there's going to be someone else, you need to agree with the other side to set up the peering. You will need to know the VPC network name of your peer and also know what is the actual project ID where the VPC network belongs to on the other side. Also remember that firewall rules still apply. This is something that you may need to tune for connectivity between the different VPC networks across the peering. Okay, we will now take a look at this in the console.
You guys don't forget to subscribe if you like our content. Thanks!
What we will try to accomplish here is that we will try to configure a peering between two projects. I've got a training project and dev project, and we have actually two VPC networks in each of these projects. What we will try to peer between is gonna be the training core and dev core, two different VPC networks, each belonging to a different project. So this is going to be an example of an inter-project VPC peering. Let's just try to communicate these two VPC networks. Maybe before we start doing the configuration, let's also quickly take a look at the actual setup here. Okay, this tab is what I'm going to use to access a training project. Let's go down to VPC network, VPC networks. We see that we've got training core under VPC networks here. This is a custom VPC that uses 10.1.1.0/24 in US East 1 region. It is also configured with some firewall roles, but the firewall rules, they only allow for egress traffic. This is what happens by default. Versus on ingress, we only permit TCP port 22, ICMP, and RDP. And we will have a similar setup on the other side. Let's go to the dev project and then down to VPC networks. Okay, this time the network is called dev-core. We use 10.4.4.0/24. This is a different region. This is US East 4. And we've got similar firewall rules in place. We will allow RDP, SSH, and ICMP only on ingress. There are no restrictions for outbound communication. If we take a look at virtual machines that we will use to test the inter-project, inter-VPC communication, we've got one instance on the dev side. This is called DVM1. It uses 10.4.4.2. Where on the other side, inside of the training project, we've got two instances, TVM1 and TVM2. This is 10.1.1/24 subnet. Basically, these two instances, they ran inside of the training core VPC network. Okay, so quickly to recap what we've got in place, we have two virtual machines inside of the training core VPC and one VM instance inside of the dev core VPC in a different project. Those VPCs belong to different regions and they are in different projects. This is what we will now try to communicate. The end result should be that we should be able to ping from the training project instances, we should be able to reach the dev instance and vice versa. Maybe before we take a look at this, let's connect to the training instance. Let's pick TVM1. And let's first see what is going to be the default behavior before we add a peering. The expectation is obviously that we should be able to reach the devices that are within the same VPC network. Based on our policy, I should be able to ping myself and also reach the other instance at TVM2 uses 10.1.1.3. Okay, so I am able to ping intra VPC. I am able to reach the devices within the same VPC versus if I were to try to get to 10.4.4.2, this obviously is not gonna work. And also if we connect to the dev instance, we should see that we won't be able to access any of the training project machines. Which is the case. And this is the expected behavior. Okay, so now we will try to change it. We will start configuring the VPC Network Peering, which is something we can access under VPC Network and VPC Network Peering. I'm going to start in the training project. We will create a connection. We will call it training to dev peering. My VPC network, actually network on the training side, is training core. This is name of the VPC network. And I want to peer with a VPC network in a different project, in another project. For this to work, I need to know the project ID. So I'm going to click on the resources here, and we will copy the dev project ID. This is what I'm gonna paste over here under project ID in the training project, and the VPC network name is, let's double check. Let's go to VPC network. VPC networks, it's dev-core. Okay, we see that by default it says that it's going to export routes with privately used public IP version 4 addresses. Remember that private IP addresses like what we use over here, those ephemeral subnets, ephemeral IPs will be reachable just based on the fact that by default the cloud is going to automatically import and export private subnets. But if you want to add some more, you want to use these additional options to account for stuff like static dynamic routes or maybe those public IP addresses. Okay, so this is how we create a peering on one side. But for the peering to work, we see that the status now is inactive. For this peering to work, we will also have to configure it on the other side. So first thing, I'm going to copy the ID of the this time training project. We will go to VPC Network Peering on the other side, create connection, continue. I'm going to say that this is for another project, which is this. Training-core is the VPC network on the other side. And we will call it dev to training peering. The VPC network on this side is dev-core. Okay, let's create. And with that in place, we should see that the status is going to eventually change to active, which it did. So I can now tell that my peering is up. You can click on the peering. You can possibly edit some of the options, like add the options to import export routes. You can do it with the peering being already set up. For tests, we will just connect to the TVM instance. Actually, let's take a look at both of these instances. So we got training instance on one side, and we will try to get to 10.4.4.2. Okay, so we see that I can reach instance in another VPC network in a different project, and this should happen for both directions. So this time I'm going to try to ping 10.1.1.2. We see that we have connectivity, but bear in mind that the VPC network firewall rules are still in place. For instance, if I were to reach 10.4.4.2 over TCP port 80 with curl, this is not gonna work unless I go to the dev project, click on the firewall menu, and add a rule to allow this communication. Let's do this. Let's go to the VPC network here. I'm gonna go to the dev core network, and we will go to the firewalls tab and add a firewall role. I'm gonna call it dev-core-in HTTP, or just in web. Let's do it for secure and insecure HTTP communication. This is dev core. Direction is ingress. This is allow. For sources, I'm gonna say that this is for anyone. This is gonna apply to all instances, and we will do this for TCP ports 80 and 443 like that. Okay, with that rule in place, when we go back and try to curl one more time, we see that the difference is that we are now getting a message. It says failed to connect. The reason it says it failed to connect is because we don't run TCP port 80. We don't run a web server on that instance. So everything is working as expected. The configuration is really straightforward, and we are now good to go.